In the late 19th century, early 20th century, scientists developed spectroscopy, and they used this to study the properties of different atoms. So in particular, they noticed that there were discrete lines or resonances that each of these atoms displayed, and in turn, this led to the development of what's called quantum mechanics, the realization that atoms consist of a nucleus with protons and neutrons and electrons, and the electrons themselves can be at discrete energy levels. As they move from one energy level to another, they emit or take in radiation, and this leads to these spectral lines that were observed. Now, the only problem with this is that the theory of quantum mechanics could only analyze hydrogen. Hydrogen is the simplest possible atom, and it consists of one proton and one electron. And once you get beyond that, hard as it is to believe, the mathematics becomes intractable, and you need to resort to numerical approximations or other things. So what happens with hydrogen? Well, in hydrogen, with the proton there, the electron can be in an energy level, but it can actually have a property called spin. So the electron can be spinning, say, in one of two directions, and this means that at each energy level, the electron actually can only be at one level, but the spin multiplies it by two effectively. This is called the Pauli exclusion principle. So here we go. The proton has spin, the electron has spin, so they can either align in spin or misalign, exactly 100 opposite in spin. When you look at this, it turns out this happens naturally and leads to a resonance at around 1.4 gigahertz, which is right around the cellular telephone bands. The wavelength of this is 21 centimeters. 21 centimeters is all over the temple of Sakarra in Egypt. How in the world did the Egyptians know anything about quantum mechanics and the resonance of the hydrogen atom with its electron and proton?